Welcome back to my today's session. We will discuss about the hurdle problem on magnetostatics. In my last two lectures, I have discussed some hurdle problems, specifically some problems of GATE and the competitive exam on the electrostatics and also about the capacitance. Today we will discuss some hurdle problems on the magnetostatics. Myself, Dr. Sayanti Chatterjee, the Associate Professor of the Electrical and Electronics Engineering in IARE. So, I will start with my first problem. A short wire of 1 centimeter carries a current of 2 ampere as shown in the figure. This is the figure. So, in the figure we can see there is a current, it is flowing. The rest of the wire is shielded so that it doesn't add any magnetic field produced by the wire. So only the magnetic field is due to this L ampere. Calculate the magnetic field at point P, which is 1 meter across the 1 centimeter. So this length is the 1 centimeter and which is 1 meter in the x direction. This is 1 meter. So what is the, this is 1 centimeter. So 1 centimeter means it is, we can write 0.01 meter. So we have to calculate first x square plus 1 square. What is the value of the x square plus 1 square? It is the root of x square plus y square, because it is a, according to the diagram, this is a, this is what I will call, this is a right-handed triangle. So what is x square by 1 square? 1 meter square plus 0.01 square, and which is almost equals to 1 meter. So we got the direction. Next we have to calculate the theta. So what is tan theta? Tan theta is equal to y by x. If it is the y, so this is our x by, which is the theta is equal to, this is the theta. So what is theta? Theta is equal to x y by x. So it will come like 0. So this is the angle, means 1 meter 1 by 0.01. So if from there we can get theta is equal to tan inverse 1 by 0.01. So we will got theta. Now according to the Bio-Savart's law, we know dH is equal to I L sin theta. H is equal to, we can write H is equal to I L sin theta by 4 pi r square. We have to calculate the magnetic field. Magnetic field means I dl sin theta by 4 pi r square, or we can also calculate B. B is equal to mu I L sin theta by 4 pi r square. So r is the distance from the point to the P point. So what is mu? Mu is equal to, we know, 4 pi into 10 to the power minus 7 by 4 pi. I is given as the 2 ampere. So current is equal to 2 ampere. So I is equal to 2 amps. It is given in the problem. Then we got the value of the DL is given as the 1 centimeter. So it is 2 into 0.1 centimeter by 4 pi. 4 pi I already wrote, r square. R is almost 1 meter. So 1 square sin theta. Sin theta. What is the theta? Theta we will get from this value. So if we solve this problem, we can get the value of the B. And what is the unit? Unit is, if we calculate this, the unit is ampere turn per meter. If we calculate like this, it is the Weber per meter square, or we can also write as Tesla. So the main thing is that we have to calculate the theta, and as the theta is this angle, what is theta? It is the tan theta is equal to y by x, or directly we can also calculate the sin theta. Sin theta is equal to x by r. We can calculate the sin theta directly also from here, like sin theta is equal to this distance x by r, because theta is this angle. If we are taking the theta as this angle, then it will be there will be a change. Next, problem number 2. There are 3 wires are at the corners of the square carrying a current of 2 amps. Current carrying of the 2 amps into the page showing in the figure. Calculate the magnitude of the magnetic field at the corner of the square. PP is a point. We have to calculate the magnetic field. If the length of each side is 1 centimeter, so length of each side is 1 centimeter. 1 centimeter means 0.01 meter. So if I write it, we can write like this: 0.01 meter. This is also from here, this point and this point distance is 0.01 meter, but from I2 to this point is always 0.01 root 2 meter, because this is the diagonal distance. And what is the diagonal? Diagonal is the x square plus y square. X square plus y square is the diagonal square. So how to get the value? We can get the value using the we can get the value using the formula. So what is this? This is the what is the formula for the each line? The h is equal to B is equal to mu I by 2r. So for the I3P at P3 point, it is the mu I is equal to 2 amps by 2r. R is equal to 0.01. Similar value we will go for the I1P, because again the distance is same. So I1P, you can see I1P direction is this. B always works in perpendicular, so the B1 direction you get it in the 90 degree. If we want to zoom it, you can see here, you can see this is little B1 is this angle. So if we zoom it, we can get the B1 value. Similarly, if we write the I3P, in the case of the I3P, the direction is this. So the perpendicular will be the B3 direction. What is B2? B2 is equal to again 90 degree with this angle, 90 degree with this angle. So if we want to calculate the B2, what is the distance between this? 0.01 into root 2. So mu I is again 2 ampere into 2r. 2r means it is 2 into root 2 into 0.01. Root 2 into 0.01. So here also 2 cancel out. We are getting 4 pi into 10 to the power minus 8. What is the unit? Unit is the ampere turn. It is the unit is the B. B is the Tesla. Here also 2 cancel out. So we can write mu by 0.01. So it is actually 10 to the power, mu is equal to 4 pi into 10 to the power minus 7 into, so it is the 10 to the power minus 5. Here also 4 pi root 2 into 4 pi into 10 to the power minus 5 Tesla. Now you can see that B1 also makes the 90-degree angle with this. So the angle with the B1, so what is the flux? Along the x-axis or along the B1P line, the flux is B1 plus B2 cos 45 degree, B2P, B3P means this direction. What is the total flux density? B3 plus B2 sine 45 degree. So we will get the flux density. If we want, we can get the total flux density B is equal to B1P square plus B2P square. We will get the magnitude of the total B. So this is the problem of this, or this is the answer of this problem. Next, two wires are carrying current out of the page, have a current 5 milliampere. The first wire is located at 0.3 centimeter and the second point is located into the 4 into 0 centimeter. So if this is the x-axis, this is the y-axis, it is written out of page. Out of page means it is an xy plane. Out of page is nothing but it's an xy plane. So one current is in the x direction, another current is in the y direction. What is the magnetic force per unit length of the current of the first wire on the second and the second wire on the first? So the distance between these two, first we have to calculate the distance between these two, because the force will work between the distance. So what is the distance? Distance is the x square plus y square. So root 3 square plus root 4 square is equal to 5. So we got the value at the 5. What is the position vector of this? The position vector is 3ay dot and it is the 4ax dot. So if we are thinking about the force on 1 due to 2, so force on 1 means the end point is the x and this is our first point, this is our second point. So force on 2 due to 1 means 4ax end point minus starting point. Minus starting point is the 3ay. So this is the direction. So what is the unit vector of the force? The unit vector of the force R12 is equal to 4ax minus 3ay divided by root of 4 square plus 3 square means 5 square. So we got 4ax minus 3ay divided by 5. So it is 0.8ax minus 0.6ay. We got the direction. Now we have to calculate the force per unit length. What is the equation of the force per unit length? Mu I1 I2 by 2 pi d into the unit vector. What is the mu value? 4 pi into 10 to the power minus 7. What is I1 and I2? I1 and I2 is the having the magnitude of the same current 5 milliampere. So 5 into 10 to the power minus 3 into 5 into 10 to the power minus 3 divided by 2 pi and d is also came 5. So what is the value? This pi cancel out. It is 2. 5 cancel out. So it is the 10. Now we are changing it in the 10 to the power minus 3. 10 to the power minus 3. So minus 6 into minus 7. This value of Newton. Into AR. And what is the value of AR? 0.8ax minus 0.8ay. So we are moving to our problem number 4. An induced EMF 2 volt is measured across a coil. The induced voltage of 2 volt is measured across a coil 50 closely wound turns, while the current through it is increased uniformly, so 0 to 5 ampere in 0.1 second. What is the value of the self inductance of the coil? With the current is the 5 ampere, what will be the flux through each turn of the coil? So first we will calculate. We know that the inductance L is equal to N I. We can write induced EMF V is equal to L di by dt, or we can write L I2 minus I1 by dt. So what is the value of V? V has given the value of 2 volt. L we have to calculate I2 from 0 to 5 ampere. So 5 minus 0 in 0.10 second. So what is the value of L? L value is 20 by 5 means 4 Henry. So we got the value of the L 20 by 5 is equal to the 4 Henry. So we got the self inductance. With the current 5 amps, what is the flux through each turn of the coil? So how to get this? We know that the flux phi is equal to Ni by inductance L. So we got the N 50, current is 5 ampere, and what is the value of L? L is equal to 4. So we from there we can get the total value of the flux. Now we are moving to our next problem. An induced EMF of 2 volt is measured across the coil 50 closely wound turns, while the current through it increases uniformly from 0 to 5 in 0.1 sec. What is the self inductance of the coil? So actually the question is little wrong. So actually this current is, this is the curve. We have to calculate the inductance. So how to calculate the inductance for this graph? The problem is little different, so I am skipping this. Okay, problem number 6. Problem number 5 is given the find the equivalent capacitance and the charge on 5 microfarad capacitor. So what is the value? 2 microfarad and 5 microfarad, both are in the parallel. So we can draw it. 2 and 5 are in the parallel. Parallel microfarad means this is the 10 microfarad and this is 3 microfarad, and with that 4 microfarad is connected. So what is the equivalent of this? The equivalent calculation is C1 C2 by C1 plus C2. Sorry, this is the 7. 5 plus 2 is equal to 7. So it is coming 21 by 10. So 2.1 microfarad. So what is the equivalent? Equivalent is the 2.1 microfarad with 4 microfarad. So what is the equivalent resistance? The C equivalent is equal to, again both are in parallel, and both are in parallel means they will be added together. So the value will be 6.1 microfarad. 4 microfarad plus 2.1 microfarad means we will get the 6.1 microfarad. Next is the calculate the charge. So this is a parallel path. So in all the parallel path, charge is same. So how to get the charge for this line AB? For the AB line, the voltage is equal to voltage is the 6 volt, because all are in the parallel line. And what is the value of the Capacitor of the AB line capacitors is the 2.1 microfarad. 2.1 microfarad. So CAB we got 2.1 microfarad. So what is the charge? The charge is equal to V into CAB. So it is coming the 12.6 microcoulomb. So this total microcoulomb is divided throughout the line. So this is constant for this line. But this and this are in the series connection. So what is the this is the 3 microfarad. We got already 12.6 microfarad. We know the voltage of this total voltage is 6 volt as they are in the parallel connection. We have to calculate the voltage across this because the total voltage of this line is 6 volt. So voltage across 3 microfarad is equal to Q by C. What is the value of the Q by C? Q is 12.6 by 3. So it is coming as 4.3 volt. So what is the voltage across the parallel line? Voltage across the parallel line is the 4.3. 6 minus 4.3 is equal to 1.7 volt. 1.7 volt, or we can calculate like this. This is the 12.6 by 2.1. This whatever you feel you can use. So we got the 1.7 volt. So what is the voltage across the 5 microfarad? So this is the 1.7 volt. So charge across the 5 microfarad is the voltage into capacitance. Voltage into capacitance, and we are getting the value. What is the value? 8.5 microcoulomb. Again, if we want to calculate cross check, Q 2 microcoulomb means 1.7 into 2 is equal to 3.4 microcoulomb, and if we add this, we will get almost 5.4 means 9, and 8 plus 3 means 11.9. So maybe some little calculation is the problem. Otherwise, we are getting the total value, Q value. Two wires are carrying the current of the same direction, 6 amps and 3 amps respectively, with 5 centimeter apart. Calculate the force in kg per meter. This is also a gate question, and the trick of the question is in only the kg per meter. So first we will calculate the force. Force per unit length is equal to mu I1 I2 by 2 pi d is equal to 4 pi into 10 to the power minus 7 into 6 into 3 by 2 pi, and what is d? D is the 5 centimeter apart. So 0.05. Pi cancel out. It is 2, and it is the 5 into 10 to the power minus 2. We can write 5 centimeter as it 5 into 10 to the power minus 2, and 5 by 3 is equal to 0.6. So we can get 1.2 into 10 to the power minus 5 Newton. We got the value 1.2 into 10 to the power 5 Newton. But we have to calculate the problem in the kg per meter. So from Newton to kg per meter, how we can get the force per length into the kg per meter is equal to 1.2 into 10 to the power minus 5 divided by what we will get? We will get the L, and what is the into divided by 9.8 kg per meter. If you take the 10, you can also take it as the 10. Then it will come the 1.2 into 10 to the power minus 6. So this is the change that we have to divide the Newton with the gravitational force. Newton by gravitational force is equal to the kg is the kg. So if we want to calculate from the Newton to gravitational force, we can get unit is the kg. Now we are moving to a problem number 7. There is a solenoid with an inductance of 0.285 millihenry, a length of 36 cm, and a cross-sectional area is equal to 6 into 10 to the power minus 4. Find the number of turns of the solenoid. So what is the formula? Mu square inductance N is equal to mu N square L by A. So what is the value of the mu? Mu value is 0.285 millihenry. Milli means 10 to the power minus 3. Mu value is, we know, 4 pi into 10 to the power minus 7. N square L is given as the 36 centimeter, means 36 into 10 to the power minus 2. And cross sectional area is given as the 6 into 10 to the power minus 4. So if we solve this equation, we can get the value of the n square. What is n square? N square is equal to 0.285 into 6 into 10 divided by 4 pi into 36 into 10 to the power minus 9. So if we solve this equation, we can get the value of the n. Suppose at a specific time EMF is minus 12.5. Find the rate of change of current at the time. We know that the induced EMF is equal to L di by dt. We got the value EMF is equal to L di by dt. So L is equal to minus 12.5 0.285 into 10 to the power minus 3 Henry. And we know induced EMF is equal to L di by dt. So what is the rate of change of current? Di by dt E by L. What is the E value? Minus 12.5 into 10 to the power minus 3 divided by 0.285 into 10 to the power minus 3. If we solve this equation, we can get the rate of change of current at a given time, and the unit will come the unit will come at the ampere per second, the rate of change of current. In the case of the EMF, as this is a physics based subject, the unit is very, very important. We are moving to the problem number 8. At the moment that the rate of change of current through an ideal inductor is increasing at a rate of 0.064 ampere per meter, the magnitude of the self-induced EMF is 0.06. What is the inductance of the inductor? Again, same problem, that we know V is equal to L di by dt, and V value is given as 0.16 volt is equal to L di by dt is equal to 0.064. So what is L? L is equal to 0.016 by 0.064 is equal to 1 by 4 is equal to 0.25 Henry. Let the inductor has a 40 turns solenoid. How much magnetic flux will pass each turn if the current is the 0.720 ampere. So what is flux? We know that the flux is equal to N I by L. So a number of turns is equal to what is N? N is nothing but the number of turns, and number of turns is equal to 400. What is I? I value is given as 0.720 ampere divided by L, 0.25 Henry. So if we solve this equation, we can get the flux passing through each turn. A solenoid with 300 turns is 300 millimeter long and 30 centimeter diameter. If the current is 500 milliampere, calculate the inductance and energy stored in the capacitor. So what is the problem? A solenoid has the n number of turns. 300 number of turns. Length is the 300 mm. Diameter mm means 0.3 meter. What is the diameter? Diameter is given as the 300 mm. What is the diameter? Diameter is given as the 30 mm. What is the meaning of the 30 mm? 30 mm means 0.03 meter. What is the meaning of the 30 mm? 30 mm means 0.03 meter. Calculate the inductance. So what is the inductance? Inductance is again mu n square L by A. So how to get the mu n square A by L? Mu value is 4 pi into 10 to the power minus 7. What is the n square? N square is the 300 square. What is the value of the length? Length value is given as the 0.3 by A. A means pi r square. If D is equal to 0.03, R is equal to 0.015 meter. Pi 0.015 meter. Pi r square. If we solve, we can get the value of the inductor in the unit of Henry. Now, what is the energy stored? Energy stored in a capacitor, in an inductor, is the half Li square. From this problem, we can get the L here. What is the value of I? I value is given as the 500 milliampere. So, if we put the value, we will get the energy stored, and the unit is in the joule. A parallel plate capacitor filled with mica having epsilon R is connected to 10 volt battery. The area of the plate is 6 meter square and separation of the distance is 6 millimeter. Find the capacitance of the capacitance and stored energy. So what is the equation? Equation is the parallel plate capacitor. C is equal to epsilon A by D. Epsilon is equal to epsilon naught epsilon R A by D. What is epsilon naught? Epsilon naught is equal to 4 pi into 10 to the power minus 7. What is the epsilon R value? Epsilon R value is given as 5. A value is given as the 6 meter square, and the distance between them is the 6 millimeter. So this value is coming 20 into pi into 10 to the power minus 4. So 2 into 3.14 into 10 to the power minus 3. 6.28 millifarad. We got the value 6.28 millifarad. after the capacitance is fully charged if the battery is disconnected. So if the battery, before battery is disconnected, the energy stored was the value half CV square. So from here we can get the value of C into V value is given as the 10 square 100. So we will get the energy in the joule. Now we are disconnecting the battery, but before disconnecting the battery, the total charge will be the same. So what is the charge? The charge Q is equal to C into V. C into V means 6.28 into 10 to the power minus 3 into 10. So the value is coming 6.28 into 10 to the power minus 2 coulomb. Now we have removed the battery and we are taking out the mica, or the it is given the mica. Mica is the dielectric. So what will happen? What will be the next new values of the capacitance? Now the total capacitance is equal to epsilon naught A by D. So same value 4 pi into 10 to the power minus 7 into 6 by 6 into 10 to the power minus 3. So this value is coming at 4 pi into 10 to the power minus 4. 10 pi into 10 to the power minus 4, and the unit is the farad. What is the next value? What is the value of the capacitance? We got charge. If we take out the battery, the charge will be fixed. So this is also fixed. Now how to calculate the stored energy? Because always battery is removed. What is the meaning of the battery removed? Battery removed means there is no charge. So how to get the charge? So another formula we will use, energy is equal to Q square by 2C. So Q square by 2C. How we are getting this value? Half CV square, or we can write half C square V square by C. C square V square means Q. So we are getting the half Q square by C. Q square by 2C. Q value is fixed. So Q's capacitance value also we got. So from there we can get the stored energy. So we have discussed some harder problem on magnetostatics here, and also one or two problem on the capacitance, and these are very useful for your some exams. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.